Recording in progress.
Okay, 36-90 triangles. This is a big deal. You guys really got to know how 36-90 ratios work. It does actually creep back in a big way much later in trigonometry. Like you do trig right now, but we do more trig in pre-calculus. So you really need to know 36-90 triangles. Also, any juniors here that took the SAT last weekend? You didn't? Okay. Well, the juniors took the SAT last weekend. First time I ever seen on the computer. They test on this stuff. So this is probably 4 or 5 questions usually deal with this type of triangle. Alex?
This is kind of sidetrack.
No, let's sidetrack us, dude. Go ahead. I think the issue was the second test was the second math section was harder, which is good. It means you did well in the first one, so it should be harder. I didn't hear any tech issues though. I don't know. No idea. Well, I'm curious myself, so I don't know. Point being is that they give this ratio on the SAT. It's actually given to you this formula, but you need to know how to use it because they do test this often. So this does come back a lot. Why is it special? It's special because the sides are proportional. Alex, you want to close the door, please?
Yeah.
Thanks. So what special relation do we have? Well, we know that the shortest side is half the hypotenuse. This is the shortest side. That's hypotenuse, so we know that. X, 2x. And then this one's kind of a funny one. It's just root 3 times x. So in the case here, the one on the bottom left of what I'm displaying right now, or middle in your packets, what is x going to equal? There you go. What's y going to equal? Root 3. Yep, just root 3. That's it. So you just follow the ratio. See how the shortest side is half of the hypotenuse? That's your hypotenuse. X. And how do I know this is the shortest side? Because opposite 30 degrees. Because 30 degrees is the smallest angle. So naturally it has to be the shortest side, right? Oh, then you follow the ratio again. So if that's so this is root 3 times this. So once you know that's 1, you do this times root 3 to get this. Exactly. Yes. Always root 3. It's always going to be consistent. If that makes sense. Another thing you could have done too is you could do Pythagorean theorem. Once you get 2 sides, you can do Pythagorean theorem like, hey, 1 squared plus y squared. Oh, geez, that looks terrible. There we go. 1 squared plus y squared equals 2 squared. 1 plus y squared equals 4. Y squared equals 3. Y equals root 3. So that works, right? But it's much easier if you just use the ratios. So let's talk about the second triangle off to the right. This guy right here. Okay, so you're given the middle side. Remember, you have a short side, which is opposite 30. You have the middle side, opposite 15. That's hypotenuse, which is 9, opposite the bigger side. Right? Sorry, opposite the big side. So what do you think x is going to be? If that's 4 root 3, and if you compare it, right? See how root 3x is like this? It'd be 4. Good. Yes, what you need to do is you need to compare. Let me clear the screen because it's getting a little busy. What you want to do is you want to compare. Root 3 times x equals 4 root 3. Root 3's cancel. What does x equal? 4. So that's 4. And what is y going to be then? Given that this is proportional. 8. It's proportion. It's all proportions, right? That's all it is. There you go. By the way, these two are similar triangles. You guys know what that means?
They're proportional.
They're proportional, exactly. Exactly, yes. That's the whole point. By the way, the SAT, they love proportional reasoning. That's why they love these kind of questions. Seriously, I think this shows 4 or 5 times on every SAT exam. This kind of stuff. Now it's 44 questions. 22 each. Was that? Yeah, usually. Yeah. They do different variations of it. So okay, let's look at these here. These are going to be a little more tricky.
Yeah, this is a little more tricky. Okay, so this is opposite 30. So I'll call this, so that's the shortest side. So what would the hypotenuse be then? Right, but what value would it be? So right, it's gonna be double. Remember, we said it's double the shortest side, right? So what's double the shortest side? Go ahead. 4 root 2. Exactly. 4 root 2. And then this side here is root 3 times the shortest side. Again, what's my shortest side? Root 3 times 2 root 2. Yes, very good. Does that make sense, guys?
Just to back up a little bit more, go too fast, or so I don't go too fast. Right, to the next problem. Do you see why that's the short side? Is the opposite way. So it's got to be the first side, right? It's opposite small thing. And we're told that. We now know the hypotenuse is double the short side when it's a 3690 triangle. So let's double 2 or 2, 4, 2, great. And then the middle side is root 3 times this. That's what I just did. But can I simplify this a bit more? Root 3 times 2 root 2.
Can I condense that a bit more? What's that condense a bit more? 2 root what? Careful. 2 root 6. Got to multiply, right? 2 root 6. Okay, good. Let's move on. That's my shortest side, right? Always good to identify your shortest side. So now what's the hypotenuse? 4. What's the middle side? Perfect. You guys are nailing it. Good work. Root 3 roughly is 1.7. 2 times 1.7 is about 3.4-ish. So that makes sense. 2, 3.4, and 4. So, okay. Just keep on moving. 45, 45, 90. And then we'll do some SOHCAHTOA. And some prax problems. And then homework will be on pages 5 and 6. Okay, 45, 45, 90. I think these are actually easier to deal with because it's nice isosceles. So what makes this one special? Still, yeah, sides are proportional. And both legs are, you guys remember that symbol? What's that symbol called? Good. Hopefully you guys are not traumatized from geometry. Don't worry, we're not doing proofs. Don't worry. Not formal written proofs, right? But the symbols you should know. You guys want, well, I can bring back proofs. No? No? No, I don't want to do it. I hate grading proofs. I only taught geometry once and I almost went crazy. I do not like teaching geometry. That's one. Congruent. It just means same. Okay. Okay, good. You guys, actually, it was the only math class, might be a Jeopardy question down the road. Only math class I ever got to be in high school. Like, that is all geometry. I cannot get an A in that class. I hate writing.
It's not math, it's memorizing the properties.
I like the stuff after the proofs. I did well on that, but not the proofs. Yeah.
Because they made us like on most of the tests to get us like name what property.
Right.
Yeah.
Okay, guys, I know we're good. The trauma's over. We're bluer skies ahead, right? So here we go. So because it's isosceles, you know two sides will be the same, right? So I know this is 9, right? It has to be 9 because the other side is 9. Then what would y equal? You use Pythagorean theorem, or you could just use the ratio, 9 root 2. So you could do 9 squared plus 9 squared equals y squared, because you already know that two angles are the same. The sides opposite must also be the same. So we know this now. It's not hard. So 162 equals y squared. Y is root 162. But when you go through all this process, it just takes a while. Just multiply the darn side by root 2, right? That's all you have to do. It's always going to be root 2 times the leg. Just choose one leg because both legs are the same and multiply by root 2. That's it. So let's do the third one. I'll do the middle one. The middle one's a little tricky. Let's do the one off to the far right. What's x going to equal, guys? 8 root 2, good. And this is going to be root 2 times the leg. Yes, good. 8 root 2 times root 2, 8 root 4, 8 times 2, 16. I know I'm being a little more long-winded about it, but I want to make sure you guys have all the details so you're not confused. So, but yeah. Okay, questions so far about the first and third ones?
This is okay? That's 9. Makes sense. 9 root 2. Good. 8 root 2, right? These are the same. That's root 2 times this. So 8 root 4 is 16. We're good. That's a root 51.
This trips people up. Why does the middle one trip people up? Because probably your middle school math program, I'm not going to blame the teacher, shouldn't do that, but your middle school math program probably didn't do the best job of teaching you guys fractions. And if you think about it, what happened at this time 4 years ago? COVID. You guys were in 6th grade or 7th grade. And they told you school's going to be closed for 2 weeks, and guess what? It's closed for a year and a half. So, yeah, that was a formidable time where a lot of the fraction arithmetic and algebra should have been solidified. And sadly, it probably wasn't. It's not your fault. It's because, there was a pandemic, right? So this is why the middle one usually people struggle with. They struggle because it involves fractions. So here's what you do. We know this is root 2 times the leg. Well, what letter am I using for a leg? I'm using either x or y, right? So guess what? Set up an equation. It's not hard. Just that sometimes we don't think to do that. Right? Root 2 times the leg equals 12, or y, doesn't matter. I mean, it's kind of dumb they put x and y because let's be honest, those are the same, right? Both legs are the same because the angles of opposite them are the same, 45, 45. So we'll just call y x because they're both the same. Now, how do I solve for x? What does x equal? Good. Close. Yes, you're correct. Now, here's where people mess up. Yes, you can say it's 12 over root 2. Personally, I'm actually kind of cool with that. As a calculus teacher, actually, I don't care if my students write that way because as long as you can do the calculus, it's all good. But it's good to clean it up a little bit, especially, and again, not trying to say, talk about the SAT like, well, the SAT is a end all be all, because not, because a lot more things that matter for college than SAT. And interestingly, actually, a lot of colleges are bringing back the SAT over the last 2 weeks. I think there's been half a dozen schools that said we're bringing it back. But regardless, you got to know how to clean this up because there'll be times in your other math class, not just the SAT, where they want this to look cleaner. How do I clean this up? Do you guys know how to clean it up? What do you do top bottom? Do you guys remember? Yeah, exactly. That's called rationalize the denominator because you're making the bottom a rational number. Remember rational numbers? Well, maybe you don't remember because I didn't tell you this.
Yeah, rational numbers never that's a ratio of 2 integers, or that's a clean number like that's a whole number or a decimal that repeats or terminates. Like 1.5 is a rational number, just 3 halves. 0.3 repeating is rational, it's 1/3. Root 2 is not rational. There's no. You can't rationalize it as a pun, I guess. It's like 1.414 and a bunch of random digits. It's kind of like pi, right? Like pi, does pi run? No. Is there any pattern to it? Not really. By the way, it is Pi Day on Thursday. Maybe I'll bring in a pie if you guys are interested. So anyway, rationalize means you want to make it a nice number. That's why we multiply top bottom by root 2. What do you get? 12 root 2 over 2, and that reduces the 6 root 2. So that's 6 root 2, and that's 6 root 2. If you rose 12 over root 2, I wouldn't hold that against you. I just think it's in your best interest to make it cleaner, just for the things you do down the road with math. So 6 root 2. And it works, because if I were to square these, I would get 72 plus 72, which is 144. And guess what? What's 12 squared? 144. So I know it works.
You didn't have to write all this stuff down. I just wanted to show you it works. Remember, all these have to satisfy Pythagorean theorem. These are all right triangles. Okay, that's clear. Okay, let's do a couple more here. Tell me what x is here. Same as the other one, exactly. And then this is going to be root 2 times the leg, which is 3 root 4. 3 times 2, which is 6, right? And then here, again, we know this is root 2 times the leg. So it becomes a memorization, unfortunately, a little bit of memorization. But if you think about it, again, if these are the same, that has to be x root 2 when you do Pythagorean theorem. Has to be. The 36 and 90, unfortunately, is some memorization. But anyway, so that's root 2 times leg. So root 2 times x, and that's x also, by the way, equals 4 root 2. So what does x equal then? So it's 4 and 4. Exactly, right. Okay, now we know that. Let's talk about trig. Okay, so there's a mnemonic that many people learn. So, ka, toa. So SOH, CAH, TOA. Very, very important that you guys don't think of this as some abstract thing. This is not abstract. Yes, it seems abstract, but it's not. It's actually incredibly concrete. It's simply a ratio of two sides of a right triangle. That's all it ever is. Sine, cosine, or tangent is simply a ratio of two sides of a right triangle. The input, that's your output, by the way. That's the output. The input is an angle. So we call this an angle. Does anyone know that letter, what that letter is called? Theta. Yep. I don't know why Greek alphabets are used. Sometimes you run out of normal alphabets. I can't tell you. I know the Greek alphabets really well, but I was never in a fraternity. I never did Greek life. I was a total nerd. But I know all the Greek alphabets because I took engineering classes. So you had to know all the Greek alphabets. So theta is one of them. So there you go. Adjacent's always right next to the angle. That's obviously opposite to the angle. Hypotenuse is the longest side. Technically, the hypotenuse is next to the angle as well, but we reserve that gets a special designation. That's going to be the hypotenuse because it's the longest side. So the adjacent is the leg next to the angle. The opposite clearly is opposite to the angle, right? And that's a little angle symbol. Sorry about that. Little angle symbol there. There's other mnemonics you can use to help you remember it, like PEMDAS, please excuse my ignorance. I remember in 6th grade, my 6th grade teacher said, Oliver has a heap of apples. I don't know why I remember that. That's like 1989. That's like 35 years ago. I still remember that. So anyway, kind of crazy. I remember random crap like that. Okay. So again, sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. That's a nice schematic, by the way. Whoever did that, maybe Ms. Wong did that. That's really nice, actually.
Opposite of hypotenuse, adjacent of hypotenuse, opposite of adjacent. So that's how it. There we go.
Or Oliver has a heap of apples. There we go. Okay, so let's work some of these out. Let's state the sine, cosine, tangent of each of the triangles. Let's find the missing side using the calculator. We'll talk about inverse trig as well, and then we're done. Okay, so we're almost done, guys. Depends on the situation. I'll tell you. Great question. Hunter asked probably one of the best questions I've heard in the last few weeks. How do we know which trig function to use? That is the essential question. That's why people get stuck with these sometimes. So it depends on the situation. Like, okay, the game of baseball. Who plays baseball? Does anyone play baseball here? Okay. So what position do you play, Jack? Okay, so you bat, obviously. You're batting, right? So is the fastball coming every time? No. Does it depend on the situation? Totally. Like if it's like a 2-0 count, probably Yeah, it's probably something else, right? If it's 0 and 2 count, yeah, maybe you might see. Yeah. Just depends on the situation, right? So we don't know until you're in the situation. But in this case, I'm asking you to find all three. So we're gonna do all three. Both triangles: sine theta, cos theta, tan theta. Sine theta, cos theta, tan theta. Okay. Let's start with sine. Sine theta, opposite over hypotenuse. What's my opposite side? 3/5. Cosine? Tangent? Other one. Easy peasy, right? Well, can I pause there so you guys can copy it down and I can eat more of my lunch?
Yeah, that's all. It's just a ratio of sides. Do I know what the angle is? No. Do I care? No. I didn't ask for the angle.
You know,
So you know what theta is? Theta is here. Great. Opposite 305. Adjacent 405. Opposite adjacent 304. It's right here. Opposite 724. Adjacent 2425. Opposite adjacent 724. That's all.
so a lot of it's just basics for today. We are gonna get more advanced stuff down the road.
Are we not gonna be solving for angles?
We will actually on this page. Will no, we're getting there in 2 minutes. Go. Now here, find the missing side using a trig ratio. Now, Hunter, this is to answer your question. Which one do you use, right? Because you have 3 options. But only one of those 3 is going to work. So you have 72 degrees, right? Okay, the 6. Is it opposite? Is it adjacent? Or is it hypotenuse? Which of these 3 is a 6 compared to the angle?
The angle's right here. Which is your last the 6. You're at 72. Jason, 70 is pretty next to it.
So it's not opposite, it's not hypotenuse. It's clearly adjacent. And then this x is opposite the right angle. What's that going to be? It's along the side, hypotenuse. Now, so, ka, toa. Which one uses a and h? Cosine. That's how you tell. That is how you tell. You got to label the sides as whether it's opposite, adjacent, or hypotenuse, depending on where it's related to the angle. So let me write that as a text box, actually. Label each given side as adjacent, opposite, or hypotenuse. All depends on how it is located from the given angle. That is it. That's how you tell. Does that make sense, Hunter? Yeah, okay. That's how you tell. That's it. So let's take a look. Next one. 24 degrees. That's my angle, right? X is clearly opposite. 12 is clearly what? Of these options, it has to be TOA. So tangent at 24 degrees. Oh, I didn't solve the first one. I'm sorry. Let me go back. My apologies. I didn't solve the first one. I got ahead of myself. So how do I set it up now? My apologies. Totally, that was crazy. I just got so carried away defining the stuff in green. Cosine 72 degrees equals what? Yeah, 6 over x. Thank you, Monsignor. Thank you, Alex. And then multiply both sides by x. And then use a calculator to work that out. Let's see here. Cos of 72 is 0.309. X is 6 over 0.309. X is roughly 19.42. Yeah, X is 19.42. Hopefully you guys can read that. It might be a glare. Let me know if you have a hard time reading that. 19.42. And it should be bigger than 6, right? It should be bigger because it's the biggest side. If you messed it up and it's 6 times 0.309, you get a smaller number. You know there's a mistake because the hypotenuse can't be less than 6. It's got to be more than 6. Another thing to caution you about too, I've seen this happen often. And actually, this would really, really suck because you probably will at best get a C on the test if you're not mindful about this. This would totally destroy you guys. I'm not dead serious. It's an easy fix, but you just got to be aware of it. I don't get very dramatic, but in the calculator, there's a thing called mode. Okay. The third line.
There's something called radian and degree. I'm gonna call it radian. Radians probably Thursday or next week. Radians is an angle, is a measure, is a unit measure. So, like for example, like with distance, you could say like from here to like San Francisco is like 30 miles. But if you live in Europe, they don't use miles. They kind of yeah, we're special. If you want, they're not the rest of us kilometers. We're saying if you go to a gas station, I put gas in right in gallons. But if you get filled gas like you rent a car in Mexico or Canada, which are these later is exactly right. So it's the same kind of thing. It's like
Different unit measure. You got to switch that over to degrees. If you don't, you'll miss it. You'll miss every problem. Now that would suck. You don't want that to happen. So please be mindful about that. I'll remind you, but you got to switch to degree mode. So that's what's happening with that one. Okay, moving right along. Tangent 24 degrees equals x over 12. Because remember that's opposite, and that's adjacent. So x is 12. $5.34. And then here, same thing again. That's opposite. That's adjacent. Which trig function do I use for a third triangle? TOA, tangent again. But now it's 14 over x. Multiply both sides by x. Tangent 49 is 1.15. I'll do it to 4 decimal places, it's a little more accurate. $12.17. Okay. So you have to use a calculator, for some of these. Some of these you just can't be done. Calculator is needed. Okay, questions? Okay, we're almost done. Just these here, and you guys can start homework. Okay, inverse trig functions. Use this. So inverse trig is exactly what it says. Input. Let me do this as a text box, sorry. Input and output switched, compared, sine, cos, and tan. Okay. They're switched. So now the input. So guys, please don't mess this up because this happens often. This is going to be the ratio of two sides of a right triangle. So that's the input. The output is the angle. So use it to help you solve for the angle. So here's my angle, right? 27. Is 27 opposite, adjacent, or hypotenuse? 38. Adjacent or hypotenuse? So which one uses OA? So tangent theta, theta will be my missing angle is 27 or 38. Does that make sense how I set that up? But you have to isolate theta. How's theta isolated? As an inverse. So you need a calculator to work it out. I'll just tell you what it is. So you have to go to your calculator, which I foolishly closed. I don't know why I did that. Let me clear my screen for a moment. Inverse tan. Now, I deliberately am making a mistake here because I didn't change my mode. That's weird. 0.6 degrees is not true. That's in radians. We'll talk about radians when we have that opportunity. There you go. That makes more sense. 35.39 degrees. What to round, I'll tell you. Usually like 2 decimal places. That's kind of my preference. What was that? 35.39 degrees. Actually, let me undo my writings. There we go. Okay, the middle triangle. What is the what's 13 compared to the angle? And the 20? So we're gonna say cosine theta equals 13 over 20. Hence, theta is inverse cos of 13 over 20. Wherever that is. 49.46 degrees. Last one. Six is what? Adjacent, hypotenuse, or opposite? Adjacent compared to the angle, hypotenuse. And then you could just do it. Like you're doing inverse cosine, right? You don't even have to keep. Kind of just get to it, right? Inverse cos of 6/8. 41.41 degrees. So the homework is incredibly straightforward. There's really nothing cryptic about it. You're just finding missing sides, right? I'm sure you guys will figure this out. This is the middle one's a little tricky, actually. Never mind, it's not as straightforward as I thought. 715 straightforward, 716 should be straightforward. And then there's some review stuff on the next page. And that's that. You guys can actually do this on the worksheet itself. You don't have to do it on a separate piece of paper. There's enough room. So we have 13 minutes, 13 minutes. You can take one of these here if you need that. Yeah, we're all set.